Okay, so this lecture we'll see some examples on the important specifications of directional coupler. We'll see a couple of examples, and we'll see some applications of a directional coupler. So as we have discussed, there are 4 specifications: coupling, insertion loss, isolation, and directivity. We have to know about directional coupler, very important device in microwave communication systems. For so many applications, we use directional coupler. We'll see some applications later. So let's see some examples on these specifications: coupling, insertion loss, isolation, and directivity. Okay, so coupling C is given by this formula. It is 10 log of P1 divided by P3. So P1 is the input power, P3 is the coupled power. Okay, the correct direction. That's what we call it C. Insertion loss is how much power loss due to the attenuation, and isolation is given by this formula, 10 log of P1 divided by P4. What is P1? Input power. What is P4? Amount of power in the wrong direction. Okay. When we see directional coupler, when you apply input signal, it must be divided into 2, one here, one here. Okay. But there is coupling also in the wrong direction. It must be 0 theoretically, but there is small amount of power go in the wrong direction, coupled in the wrong direction. That's P4. So isolation and directivity calculates what? P4. How much power go in the wrong direction? Let's see these examples. Okay. So our first example, we have given, this is our solution. Okay. Solution for this example. So what are the given? C is given. This coupler C is 10 dB. 10 dB coupling is given, as you can see here, and directivity is given, which is D. Directivity, we call it directivity. How much? 40 dB directivity. So when you buy a directional coupler, when you use a directional coupler, this coupler has 40 dB directivity and 10 dB coupling C. Another given is input power. P1 is given. So how much power applied? 10 milliwatts. Input power applied here. So this voltage will be, this power will be divided into 2 by this coupler. Okay. So how much goes to the direct port? How much power goes to the coupled port? And how much power goes to the wrong direction? The isolated one we'll discuss. So what is the requirement? We are asked to calculate P2, P3, and P4. What is P2? How much power transmitted directly? How much power goes to the wrong direction? Sorry, the right direction, coupled port. And how much power go in the wrong direction? P4. How much power goes in this direction? So that's what we are going to calculate now. Okay, so let's start from the first one. C, what is the formula? For coupling, C is equal to 10 log of P1 divided by P3, right? Coupling compares P1 with P3. So how much C? C is given here. It is 10 dB. So substitute C 10 dB. This coupler is 10 dB coupler. So it will be 10 log of how much input power we apply. We apply here P1 is 10 milliwatt. Okay, so 10 milliwatt power, input power P1 is 10 milliwatt. We don't know P3. We have to calculate what? P3. How much power sampled in the correct direction. So to calculate P3, let's divide it by 10, both sides. So this 10 get cancelled. 10 by 10, it will be 1 is equal to log of P1 is 10 milliwatt divided by P3. Okay, so this logarithm is the base 10. So 10 to the power of 1, 10 to the power of 1 is equal to log now will be cancelled. So 10 milliwatt, 10 milliwatt divided by P3. So what will be P3? Power coupled power, P3 is equal to this 10 milliwatt divided by 10 to the power of 1, 10 milliwatt divided by 10 to the power of 1 is 10. So 10 by 10, how much? 1 milliwatt power is P3. So we know P3 now, right? From C, you can calculate P3. How much? We apply 10 milliwatt. Now 1 milliwatt goes in the port 3. Okay. So when you see directional coupler, if you apply 10 milliwatt signal here as input, 1 milliwatt is sampled now. 1 milliwatt. Why? Because this coupler has C10 is equal to how much? 10 dB. So C determines how much power sampled, how much power coupled to the coupled transmission line P3. Okay, next, we need to calculate P4. Okay, so P4, how much power go in the wrong direction? We need it to be 0. We need all the sample signal goes to P3, but due to design imperfection, small amount of power coupled in the wrong direction, P4. So how to calculate that? We use the formula D. Directivity is equal to, what is the formula? 10 log of P1, the input power, divided by P4. Okay, so how much directivity is this coupler? Directivity is given, it is 40 dB. So D is 40 dB, which is equal to 10 log of P1 input power. How much? Is 10 milliwatt input power. So we need to calculate P4. Okay, how we are going to calculate? Similar procedure. Divide this by 10. Divide this by 10. So 10 get cancelled. 40 divided by 10 will be 4. Is equal to log of 10 milliwatt divided by P4. Okay. So again, this is logarithm the base 10. So 10 the power of 10 the power of 4. Now the logarithm will be cancelled. So what remains? This part, 10 milliwatt divided by P4. Okay, now we can calculate P4. What's P4? P4, 10 milliwatt divided by 10 to the power of 4. 10 milliwatt divided by, what is 10 to the power of 4? 10,000. It will be 10,000. So how much P4? 0.0 10 divided by 10,000. 0.0001. Right? Am I right? 1, 2. Sorry, it is 0.001 milliwatts. Okay, you see how much power it is? Very small amount of power. 0.001 milliwatt goes to P4. When you see a directional coupler, here we apply 10 milliwatt, which is P1, transmitted through this wire. Now, when it reaches here, it's divided into 2. This will be our P2, direct signal transmission. This is P3, coupled transmission. But there is small amount of power go in the wrong direction also. That's P4. How much? 0.001 milliwatt. How much P3? 1 milliwatt. Okay, this 1 milliwatt signal sampled in the correct direction. 0.001 milliwatt, very small power, go in the wrong direction. Okay, before we need it to be 0, but practically there is some signal coupled and go in the wrong direction. So here, if you apply signal must be divided into 2 here. 1 go to P3, 1 go to directly to P2. But there is small signal comes in the wrong direction, P4. Okay? That's what we call it directivity, D. Okay, so D compares what? Compares P1 with P4. C compares what? C compares P1 with P3. Both P3 and P4 are coupled, but P3 is the right direction, P4 is the wrong direction. We need all sample signal going to P3 only, but there is small leakage, unwanted coupling in the wrong direction, P4. So now what remains? How much will be P2? How much will be P2 here? Look here, if you apply 10 milliwatt, 1 milliwatt go to P3, 0.001 milliwatt go to P4. The remaining power will be P2. So what will be P2? P2 will be P1, input power, minus power goes to P3, which is P3. Power goes to wrong direction, so minus P4, minus loss, attenuation. That's P2. P2 will be the input power minus what? 2 couplings here, 2 samples. They diverted into another direction, P3 and P4. P4 must be 0, but there is small amount here and loss here. So in this case, this example, we are asked to assume there is no loss. So what will be P2? P2 will be the input power we apply minus P3, the couple power in the correct direction, minus P4, couple power in the wrong direction, minus the amount of attenuation. But here, assume loss 0. So what will be P2? P1 how much? 10 milliwatt, right? Minus how much P3? 1 milliwatt. How much P4? 0.001 milliwatt. So this will be how much? It will be 8.99 around this milliwatt. You can determine. Okay. So 8.99 milliwatt will transmit directly from P input to output, but the remaining signal will be sampled and go to the P3 and P4. Let's see another example here. Okay, example number 2. In this case, what's the given? This is our solution for example 2. Okay, our coupler in this case is 6 dB. So C is how much? 6 dB coupler. The previous example we used 10 dB coupler. Now this coupler we use is 6 dB coupler. So C is D. How much directivity? Directivity D is 30 dB now. Okay. So C is 6, D is 30. And again here, the input power is P1 is 10 milliwatt. Okay, so let's continue. So input power is 10 milliwatt. C is 6 dB. D is 30 dB. Input power, P1 here you see, input power, we apply 10 milliwatt signal from port 1. Now, signal will transmit directly to port 2, show port or direct port. But signal also transferred to another transmission line, and it will go to 2 directions, P3 and P4. Okay, theoretically we don't need power here. All the couple signal must go only to couple port. But due to design imperfection, there is leakage in the wrong direction. So let's calculate P2, P3, and P4. So let's start from C. C is equal to 10 log of P1 input power divided by P3, right? You know the formula for C. In this case, this coupler has how much coupling? 6. C is now 6. So 10 log of P1 is 10 milliwatt. P3 is, we need to calculate P3 here. So what we should do? Again, divide both sides by 10. So 10 get cancelled. 6 divided by 10 is 0.6. Right? Then we have logarithm of input, which is 10 milliwatt, divided by P3. Now this is log base 10. So again, 10 the power of 0.6 in the power of 0.6 is equal to, now the logarithm cancelled. So we have here 10 divided by P3. 10 milliwatt divided by P3. So how much power sampled this coupler? 10 to the power of 0.6 is 3.98. Okay, 3.98. So 10 milliwatt divided by P3. So what will be P3? P3 will be 10 milliwatt divided by 3.98. Okay, that's our power here. 10 divided by 3.98. How much is this? 2.51. So this will be 2.51 milliwatt. Okay. So you see, if the coupler is C, the previous example here, when coupling is 10, the same amount of power, 10 milliwatt input, how much power is sampled? 1 milliwatt only, 1 milliwatt. Now when you use another coupler with lower C, C now becomes, in the second example, C is 6 dB, right? Here this is 6. When C becomes low, we get more power sampled. P3 becomes 2.51. The previous example, we sampled only 1 watt, right? From the signal, we sampled only 1 watt. But here now we take C, we decrease C, so we take 2.51 milliwatt sample. Okay. Why we need to take a sample from a signal? If signal transmits directly, we take small sample by coupler. Why we need to take some sampler? It's for monitoring purpose, to check your signal continuously without interruption. Signal is transmitted, but you can take small signal sample to check, to test what frequency, what is power, what noise, interference. We need to test our signal by taking what? Samples. Just like doctors, when you go to hospital, they will take small sample from our blood, small sample, to check whether we are sick or we are okay. They take samples, right? Small. They are not taking all the blood. They take only small amount is enough to check. Similarly here, by using a directional coupler, we can, transmission is still going on, but we can take small sample from the signal, go and analyze using power meter, spectrum analyzer. You can determine your frequency, you can measure power, you can check, is there any interference? Our signal, is it okay, or is there any noise? To do this checking, we need to take sample. Which device is used to take sample? Directional coupler. Okay, that's why it's very important device, what we call it directional coupler. How much sample we take depends on the C value. If C increases, the amount of sample decreases. Okay, if C decreases, the amount of sample we take increases. So in example 1, this directional coupler, C10 dB coupler, from 10 milliwatt input power, how much sample we take? 1 milliwatt here. Okay. Now, if you use another coupler, 6 dB coupler, we increase the amount of power sample from 1, it increases now to 2.51 milliwatt. That's what we call it C coupling. Okay. So in the first example, this coupler has directivity 40. So when you calculate P4, how much we get? We get 0.001 milliwatt. Okay, this power is sample, but it goes in the wrong direction. Now in second example, how much directivity for this coupler? 30 dB. This directivity indicates how much power P4, how much power sampled and go in the wrong port, the wrong direction. Now let's see in this example how much power coupled in the wrong direction. So P4, sorry, D is equal to what is the formula for D? 10 log of 10 log of P1 divided by P4. Okay. So D in this coupler, this D has 30. The previous one, the previous coupler has 40 dB directivity. This coupler has only 30 dB directivity. So let's check. So 10 log of what is P1? 10 milliwatt, right? 10 milliwatt. Sorry, 10 milliwatt divided by P4. Okay, so divide both sides by 10. Divide both sides by 10. So this 10 cancelled. 10 divided by 30, it will be 3 here. So it will be log 10 milliwatt divided by P4. Okay. Now this is logarithm of the base 10. So 10 to the power of 3. To cancel the logarithm, 10 to the power of 3 is equal to 10 milliwatt divided by P4. So 10 to the power of 3 is 1000. So what will be P4? P4 will be this divided by this, right? So 10 milliwatt divided by 10 to the power of 3. 10 to the power of 3 is 1000. So how much P4? It will be 0.001. Sorry, it will be what? 0.01, right? Milliwatt. So the previous case, how much power goes in the wrong direction? 0.001 milliwatt, very small. Now when directivity decreases, in this case directivity is 40. Second example, this coupler has directivity 30. Directivity 30. This much power goes in the wrong direction. So directivity 40 dB coupler, the first example. Okay, in the first example, how much power goes in the wrong direction? 0.001 milliwatt. Now, if directivity is second example, when it becomes 30 dB coupler, how much power goes in the wrong direction? 0.01 milliwatt. So which coupler is good quality? First one or second one? The first one is good quality. Okay. The higher the directivity, minimum signal goes in the wrong direction. When D decreases, P4 increases. Signal will go in the wrong direction, increases. We don't need that. We need only at P3. All sample signal go to P3, right? But if you use directivity less, more signal will go in the wrong direction. Okay, so when you buy a directional coupler, you have to check the directivity, D value. D higher is the better. Okay, the higher directivity coupler has minimum leakage, minimum coupling in the wrong direction. That's what D means, directivity. Okay, so let's see some applications of this directional coupler. So here the first application we are going to see is monitoring circuits. So as you can see here, we have a monitoring circuit. This is our coupler here. This is our measuring device. So look here. When you transmit signal from circuit 1 to circuit 2, signal is transmitted, right? Signal is transmitted from one system to another system. Now, how we are going to check this signal? How we are going to monitor? What we have to do? If you have two systems in telecommunication, okay, system 1 and system 2, signal is transmitted directly from system 1 to system 2. Now, how we are going to check our signal? How we are going to monitor? Is power level, is it good? Frequency, all this we have to monitor, right? For good communication, always we need to monitor our signal. Which devices are used for monitoring? Power meter, spectrum analyzer, oscilloscope, all these devices used to check our signal. So how to take signal transmitted? We are not interrupting, okay? Without interrupting, how we are going to take small sample from this line, from this transmission line. This is transmission line, transmit from 1 to 2. So what we have to do? Connect here, bring a coupler, connect in between the two. So this is port 1, this is what? Port 2. Signal still transmitted directly, but we take small sample and give it to our meter. Here we have a meter, power meter or spectrum analyzer, okay? You see here, this is our, let's say, our power meter or spectrum analyzer. Connected to which port? Port number 3. This is port number 1, go connect to the system 1. Port number 2, connect to system 2. Signal is still transmitted without interruption, but by coupling, small amount of sample goes to our power meter, because the power meter is connected where? Connected at, look here. So, this is our coupler. So we connect our system 1 to this port, port 1. So this is our system 1, maybe our transmitter, okay? Transmitter. Port 2 connected to our antenna here, okay? This is our antenna here. This is antenna. So still signal transmitted from antenna, so transmitter to the antenna. Through what? Through the coupler. So how we are going to check this signal? How to monitor it? This coupler will give us a small sample at port 3. So port 3, take a cable, connect your meter here. So you'll get small signal at port 3, go to the meter. So you can check how much power you can measure. You can check frequency level, any other characteristics of the signal, you can monitor here. Without, still communication is going on. Still transmitter is transmitting to the antenna. But the coupler helps us to take small amount of power for monitoring purpose. That application is one of the application of directional coupler. We call it monitoring circuits. Okay.